So hello, good morning everyone. And today we are going to see about the binary numbers and the working of computers, how the binary numbers which is used in computers. So while possessing a base knowledge of mathematics is not necessary to learn computer programming. It is certainly helps to have a basic grasp of some of the foundational mathematics that makes computing possible. And what could be more fundamental to modern computing, the binary mathematics? The term binary means something that has only two possible objects or states. In the binary number system, these two objects are the numbers 0 and 1. These two numbers can be represent a variety of things. For example, in computer logic, 0 represents false and while 1 represents true. Or they could be used to represent ordinary numbers as combinations of ones and zeros. An example of this would be the representation of numbers 0, 1, 2, 3 and 4 in three binary digits as 000, 001, 010, 011 and 100 respectively. But what does this all mean at the fundamental level of computing? Why is the binary number system used as the foundation for all our computing? Perhaps it would be easier to understand all of this if we can understand the basic working of computers at the machine level. Zeros and ones interrupting the workings of computer circuits. So computer operate on the electrical signals generated by these circuits. In order to design a computer that runs efficiently, we need a system that can interrupt electrical signals in a simplified and effective manner. A good way of doing this to interrupt electrical signals as binary values 0 for a low voltage and 1 for the high voltage value. An easier way of thinking about this to imagine a light bulb. If the bulb is off, the state is the bulb is off, the state is interpreted as having the value 0. If it is on, it is interrupted as having a value of 1. This broad generalization reduces the range of interpretation of each electrical signal into two distinct values. Instead of an infinite range of continuous voltage values, with this method of operating and interrupting electronic circuits in a place, we can proceed to design coded system based on the binary bits to aid in our computational task. This system could be binary logics restricted only to true or false values. Base 2 numbers representation of numerical values or using other systems that rely on a series of binary numbers to represent text, pictures or sounds. Essentially, our computers use a series of high voltage and low voltage electrical signals, that means binary values, to represent everything from text and numbers to images and sounds. There are special electronic circuits such as flip-flops and other circuits that can store or retain the specific patterns of electrical signals for extended use. For instance, one flip-flop may have a number of inputs that currently has a high voltage output which we interrupt as A. Suppose the next two flip-flops have low voltage output 0. We could combine these three outputs to get a value of 100, which in binary is the same as the number 4. Understanding binary numbers can thus help us understand some of the fundamental of computer operations at a sufficiently abstract level, even though our feeble human intellect might never allow us to understand full complexity of computer operations. And that is just as well for working with simplified and abstract conception of computer operations is more than adequate for us students of computer science. In the sections that follow, we will take a brief look at some of the different ways computers use binary symbols to perform some of its most fundamental operations. Boolean logic, using binary numbers to understand computer logic. So computer program use a very specific system of logics to carry out their instructions. This known as Boolean logic. Formulated by the English mathematician George Boole during 19th century, Boole developed a system of arithmetical and logical operations that utilize the binary system of numbers. Boolean logic deals with only two possible values, true or false. True represented by 1 and false is represented by 0. All logical operations result is only one of these two binary values. Modern computers use this form of logic to make decisions all the time. This decision is in our computer taking a particular course of action instead of another. To realize how crucial this system is for computers, one need not look any further than existence of logical operators in most programming languages and the AND, the and or not operators. These operators are directly taken from and or and not operation from Boolean logic. And anyone with curiosity knowledge of programming knows that these operations are central to programming. But the influence of Boole's work does not end there. In fact, many programming languages have data type named Boolean, which can only store either true or false, that is 1 or 0. This Boolean variable and logical operators are fundamental components used in implementing conditional statements and the control statements in programming languages. As a result, their importance cannot be overstated since this programming 101. There are also many other more creative and more sophisticated ways we can use binary numbers in programming languages. However, this blog post serves as mere overview of some of things binary numbers can be used for. As such, we won't be diving into any technical programming details. Perhaps I will explore more of those topics in later blog posts. For now, let us just explore the simpler topic of numerical representation in computers. The next is representing numerical values in base 2. So numerical values are represented in our computer system in some form of the base 2 number system. The normal numbers we use in everyday life is the base 10 number system. For instance, the number 135 gives us a value of 135. As we can see from the image above, each digit starting from the right side is multiplied by increasing the powers of 10. Starting with 10 star 0 is equal to 1, then 10 star 1 is equal to 10, and finally 10 star 2 is equal to 100. The more the digits, the more the succession of powers of 10. This is the reason why this natural number system is called the base 10 number system. The base 2 number system works in the same way, except that we multiply each bit, a binary digit, with successive powers of 2. As an example, let us take the base 2 number 1011 and see what base 10 number is represents. As we can see, the binary number 10111 is equivalent to the number 11 in base 10. Of course, the way binary numbers are grouped also matters. We know that 1011 represents the number 11 in base 10. But what if we group that same series of bits as 10 and 11? Are they two different numbers, 10 and 11? Or are they a single number, 1011? This shows us the importance of the way we group our numbers. And in computers, the numbers grouped in a lot of different ways. For instance, the integers data type int in C++ stores a single number and series of 32 binary numbers. So the base 10 number is 0 represented by series of 32 zeros, while the number 1 represented by 1 preceded by 31 zeros to its left. The next is textual and character representation. We have seen that the base 2 number system forms the basic numerical representation in our electronic device. And while this is true for systems to textual representation, their working are quite different. The most common system for representing characters or ASCII, that is American Standard Code for Information Interchange, and Unicode, which is an extension of ASCII. These systems assign unique numeric values to characters and store them in binary format. For instance, the ASCII systems originally used 7 bits to represent character. Currently, that has been extended to 8 bits. As an example, the character A is represented by a numerical value of 65 in ASCII. The binary for 65 is 100001. Notice that the binary representation consists of 7 bits. It's extended ASCII. This will be stored as 01000001, so that the total number of bits is 8. Similarly, the ASCII code for the character A is 97 and it's represented by 01100001 is extended ASCII. There are also very special characters that are represented by 0, 1, 2 and so on. This system serves well for representing English and certain European characters and symbols, but it is woefully inadequate for representing symbols from languages across the world. In order to accommodate for the symbols, Unicode was developed. Unicode originally used 21 bits per symbol as opposed to 7 bits originally used by ASCII. This greatly expands the range of values that can be used to represent characters. The original ASCII codes are accommodated within the Unicode system. Currently, an encoding system based on Unicode called UTF-8 is the most commonly used encoding system in web publication. The UTF-8 can use up to 32 bits per symbol, which means it can represent an even larger variety of characters. So the next one is, so these are the important things and how the binary number it is used in computer. Thank you.